These are the answers to Unit 7 Multiple Choice Quiz A. There were lots of little questions on lots of problems. All right, the first one says the mean and standard deviation of a random sample of 7 baby orca whales were calculated as 430 pounds and 26.9 pounds, respectively. Assuming all the conditions for inference are met, which of the following is a 90% confidence interval for the mean weight of all baby orca whales? So the key to this one is building the confidence interval formula, which you should either memorize or pull off the formula sheet. I would suggest memorizing it, it's a lot faster. Matching up the information you were given, the mean is 430 pounds, the standard deviation is 26.9 pounds, the sample size is 7, and you need to find t star either by finding inverse t on your calculator or using the t table in the formula sheet you're given, going to 0.05 and 6 degrees of freedom, and finding out that t star is 1.943. We're using 0.05 because 90% confidence means that you're covering the middle 90%, which leaves 5% in the lower tail and 5% in the upper tail. So E is the correct solution. The next question talks about the study of an effectiveness of a certain adult reading program, and the question says, which is the most appropriate inference procedure for researchers to use? So go read the information and decide which is the best process. Keywords here are pre-test and post-test. Anytime you see those, it's a match pairs procedure because your two groups are not independent, they're dependent. So one sample is out, two sample is out. This is when you have independent groups. Match pairs is the correct choice. We use inference to make a conclusion or an interval about a population number, not a sample number. So choice C is the correct answer. Question 7, to estimate the average cost of flowers, and there's a lot of information, and your job is to figure out whether or not the conditions for inference have been met. Since this question is dealing with inference about a mean, you should know that the conditions, there are two of them. First, random selection from the population, and second, we'd like to have a normal sampling distribution. That can be satisfied one of three ways. If you read what you were given, you were told it was a random selection, so the first one is met. You weren't told that the population was normal. Your sample size is below 30, so we have to go with the third option, which is we hope that there's no skew or outliers in the sample, and you were told your sample is approximately symmetric with no outliers. So a T procedure is acceptable, and yes, all the conditions have been met. Question 13 says a certain region of the country elk can cause damage to agricultural crops. You're given a 95% confidence interval, and it's your job to interpret it and figure out which of these statements are acceptable. So while we use a confidence interval to create a range of values that we believe the population proportion sits inside, there are certain things we can't say. We don't know that the population, I think I said proportion, but it should be mean. We don't know if the population mean is 4. Yes, it's inside there, but we don't know if it's exactly 4. This one is out because 2 isn't even in the interval. C is the correct one. I'll come back to that in a second. Because the interval is above 2, this statement doesn't make any sense. And often your sample mean is not the same as your population mean. If it is, that's great, you got lucky, but often this is not true. So because the entire interval, our estimate for the population mean, is above 2, we can make this kind of a conclusion. The mean number of elk across all fields protected by the fence is greater than 2 per month. This question is specifically asking about properties of a T-curve or a T-distribution. What happens to the T-curve as degrees of freedom increase? So you can look in a book or you can look online for a picture of a T-curve, but basically T-curves look like Z-curves or normal curves, but as the degrees of freedom increases, you're moving from the green line to the blue line. And the green line to the blue line to the Z-curve, the center part increases, but then that means that the opposite happens at the tails. The normal curve is the lowest. As you go from small sample size to big sample size, you go from fatter tails to thinner tails. So the tail area gets smaller, center remains constant, and the area in the tails decreases as the sample size increases. Question 11 gives you a 95% confidence interval and asks you to interpret it. Most of this question centers around what does 95% mean? We are 95% sure that it captures the parameter. Sure is a level of confidence for the process, not for the results. The best option is B. We are 95% confident in our work or in our process. Okay, we are not 95% sure that the sample is inside there. 95 should not be applied to the results. It should not be applied to the parameter. And we don't know what the center of the population is, so we can't create a 95% range around or using those two endpoints of your interval. And then finally, the last one. A researcher studying the sleep habits of teens will select a random sample of N teens from the population to survey. Your question is again, which of the following is true about the T distribution as the value of N decreases from 40 to 20? Know your T curve properties. Using the same picture as before, as T decreases from 40 to 20, as you're going from the blue curve to the green curve. The blue curve is 12 degrees of freedom, the green curve is 4. Blue to green means that the tail area is going up, so your choose increases. As the sample size increases, the tail area goes down. As the sample size decreases, the tail area goes up. Okay, that's it. That was kind of a long one because there were lots of little questions, so I thought I'd end with a little video of me teaching a couple of my daughters how to dance. You're welcome.